Hello everyone, welcome to another episode of Tantra's Mantra, where we go behind and beyond the tech news headlines. I am your host Prakash Sangam, founder and principal at Tantra Analyst. As we all know, just a couple of weeks back we had Mobile World Congress, the world's biggest mobile show. Many of us did our yearly pilgrimage to Barcelona to attend it. I had to unfortunately cancel my trip at the last moment because of some personal emergency. I'm sorry to have missed the action live from Mobile Congress, but in fact, I was checking out and following all the happenings online, being here in San Diego in the US. So, Mobile World Congress this year was back to its old glory with more than 100,000 visitors, as mentioned by GSMA. The event also gave a peek into the future, especially on how the future of 5G is shaping up. All of us were hoping that we could get answers to some of the pressing questions, such as when will the most awaited next phase of 5G will arrive, when will all those exotic 5G apps and services we have been talking about for years will come, how and when will 5G operators start to see the return on the enormous investments they have done for their 5G deployment and so on. I'm not quite sure we got all the answers, but we at least got to see where the market is headed and so on. And to discuss all of that, I have John Smee, SVP of Engineering and Global Head of Research at Qualcomm with me. John, welcome to the show.
Thanks very much. Great to be here.
Perfect. So, Qualcomm is an undisputed leader in wireless and has been a driver for new technologies and new standards for a long time. What you guys are cooking, John, in your labs today is what we will get in our hands in the near future. So, our listeners are really eager to know what you guys are really cooking in your labs right now. Right. So, let's get started. So let's start with your background. I've known John for a very long time, going back to my time at Qualcomm. So, John, I think you spent almost a quarter century at Qualcomm, right? How has been your journey?
Very good. And that's exactly right. I've been here around just over 24 years. So I started in the right at the very beginning of January 2000. And it was a very exciting time to join Qualcomm when the industry was and had fully digested CDMA and it was starting to evolve. And so I jumped in actually first working on helping bring data into cellular as
Mhm.
part of EVDO. And that evolved obviously with the ecosystem and WCDMA setting the stage after that. But absolutely, it's been a fun, long journey for me.
Indeed, CDMA 2000. I still remember those golden days. Yeah. So I know. I mean, telecom industry, as we have seen, has been in ups and downs. For some time, and it has seen its great days as well, coming after the troughs. So I think it's in a little bit of a flux right now, especially after successful 5G eMBB enhanced mobile broadband deployment. I mean, it's worldwide deployment, and people are really enjoying the benefits of 5G speeds and capacity and so on. But we still are not very clear on where the next phase of growth is going to come from, especially when and what some of the applications and services we get to see. What do you think?
I think we're starting to see more and more different types of devices. I think even looking at the launch of those very initial 5G smartphones 2019, 2020, and then
Mhm.
now kind of fully coming out of the COVID era. I think that was evident also in Barcelona, that kind of physical energy to the show. And very,
Mhm.
very sorry to not see you there in person, but it really was kind of back to that industry expansion feel in terms of not only obviously global operators and vendors, but also just from the technology and ecosystem standpoint, a lot of enthusiastic participants saying, hey, where's wireless going next? Where's 5G going next? And so we
Mhm.
did see some of that renewed focus on new types of devices. And then also the interplay, I would say, between consumer and enterprise. I think that was an
Mhm.
underlying theme that in terms of how the global community is looking at that continued 5G expansion and evolution.
Indeed. So I think enterprise is going to be key for 5G to go forward, right? I think, of course, consumer is a huge business, but I think the new capabilities that are coming in are really key for enterprises. So from that context, what are some of the key takeaways that you got from Mobile Congress this year?
I would say the key takeaways for me was really this perspective that not only was every single booth, including Qualcomm's, really advocating for the opportunities of AI, but it was also
Mm-hmm.
a recognition that AI is really not just a cloud story. There's a huge focus of on device AI. And then that brings in
Mm-hmm.
this perspective of, what is in the user's hands? Is it a, 5G connected laptop? Is it a smartphone that has amazing AI capabilities? Is it,
Mm-hmm.
a wearable pin? Is it something, that, as an example from the company Humane? Is it
Mm-hmm.
something where smartwatch, XR, new types of glasses? So there's an interesting kind of energy around the fact that we're all still living in this physical world and we're all going to be more connected, but that
Mm-hmm.
connectivity is really intertwined with data and AI. And so for
Mm-hmm.
me, the kind of takeaway from the show was the infusion of energy around the fact that communications and computing are
Mm-hmm.
more intertwined now than ever. So it's not just about, secure connectivity to the cloud. It's really more
Mm-hmm.
about the fact that there's going to be a lot more computing on a much wider type of devices, and that
Mm-hmm.
people are going to be using those devices in new creative ways because AI itself is opening up new productivity enhancement applications.
Indeed, and some of the new use cases and applications, especially, what 5G is really famous for, low latency and such, need a stand-alone, right? And the standalone progress has been really slow. I think that's in a catch-22 situation where app developers are looking at wider deployment of 5G standalone, and operators who have done enough, investments in NSA, looking for enough groundswell of support for or the need for 5G standalone kind of use cases and applications to deploy it widely. So how do you think we get out of this gridlock?
I think that was also another positive coming out of the show was that because I was challenging many
Uh-huh.
operators in all of our discussions
Yeah.
in meetings, and the answer was that there is a continues to be a lot of that expectation that SA is actually here now. So there was a lot of feedback that there is a lot of investments being made right now, and that SA
Hmm.
is indeed coming online in more and more markets. So I was actually positively you know, excited to hear that that investment in SA is happening. And as you say, it's kind of intertwined with the fate of RedCap, which
Yeah.
relies on the 5G core. So the good news is with the kind of those initial deployments getting that ran out there for release 15, 16, that kind of pivoting back to operators looking more holistically at their
Hmm.
networks and saying, hey, we now want to move to the 5G core, recognizing that it brings with it slicing and other capabilities, and also just a more modernized architecture. So, kind of the evolution from 4G into 5G on the core side is also just about the overall operational efficiency of these networks going forward. So, I do feel that the that migration to SA is indeed well underway, and that that's going to continue to open up new interesting opportunities, beyond just consumer mobile broadband.
Indeed. So when I talk to operators, I mean the challenge for them for SA was there are all of these. There's quite a few of these niche enterprise applications which on their own look really impactful and interesting, but they did not have enough of them to that will kind of propel the whole network upgrade to stand alone, right? So that was one of the challenges that they had so far. And I think Red Cap that you mentioned, it's one of the 5G advanced features, seem to have that kind of one traction and broad interest wherein it'll create the groundswell for the network wide need for standalone, and then that might make them make rather switch to standalone quicker. What is your view? And also some of what are red cap is one, would love to hear the feedback that you guys have gotten from the ecosystem about red cap. I was actually surprised by how much traction there is, but would love to hear from your point of view, and also other 5G advanced features that are seeing some interest from your ecosystem.
Yeah, so it is exactly that point that as the operators are looking forward, they're starting to say, hey, as I'm moving my network to standalone, then I'm starting to realize there's more different types of devices I connect with RedCap. And I would
Mm,
say that's one of the interesting thing from the module side, the power consumption side, and even the very reasonable data rate capabilities, like a couple hundred megabits per second. So
mm,
this RedCap is kind of fitting a very is interesting niche of bringing cellular connectivity to new
mm,
types of applications. And so it's something whether it's looking at different types of tiers of FWA, different types
mm,
of tiers of even connecting laptop devices, connecting more tablets. You're starting to see that price point bring in just more connectivity into cellular itself. And I think that that's the part of the energy where, yeah, Qualcomm launched the SDX35 last year. But what was
mm,
interesting from the design win standpoint, from the pipeline of interest, we're starting to
mm.
see more and more creative solutions entering the market of, hey, I can actually bring cellular connectivity into this application, doing it on a 5G going forward basis, leveraging the fact that we have RedCap. So I think there's that enthusiasm to be investing into the future. And that's in some sense what RedCap represents. It's that, you know, carrying on the journey with 5G as 5G continues to evolve and the networks, move forward with further improvements, that you're on that, 5G RedCap train.
Yeah, I mean, even in the 3GPP, when the discussion on RedCap started, variables were in one of the hero use cases, right? But in talking to operators, I mean, I was talking to somebody in the Middle East, they're using red cap to kind of looking to use red cap to even tier their fixed wireless access. So I was really surprised to hear that. And when getting 5G into or even cellular connectivity into laptops has been a upward an uphill battle so far, but with I think redcap the price points are coming such that integrating connectivity into laptops and making them connected laptops, 5G connected laptops, seem to be fitting the bill pretty nicely in terms of how cost effective it is and for the performance it can provide and so on, right?
That's exactly right. It's hitting this kind of mass tier volume calculation that it's bringing, as we say, cellular connectivity to applications where you don't want to just be on Wi-Fi and
Mm,
roaming and logging in, and obviously, as you mentioned, even new markets for FWA where it's not a gigabit per second market, but it's more, hey, 200 megabits per second can really support a lot of different application scenarios for FWA as well. So we are starting to see that kind of more and more design wins, more and more creative solutions to to execute on the red cap opportunities.
indeed. So another interesting thing in 5G advanced is the introduction of AI, right? And there are a lot of questions to begin with. It's only starting with channel estimation. Even there, how the cross learning between the network and the device would work. What is kind of the framework for them to work together, right? Without not against each other and so on. So how is that been coming along in release 18?
Yeah, so Release 18 did a really good kind of end-to-end study on the opportunities for bringing AI into the air interface, right? Because we've always had the ability to use more and more intelligent algorithms, whether it's smarter networks or devices that are able to improve modem performance by bringing in AI concepts,
Mm-hmm.
above the traditional transmitter and receiver algorithms. I think what's exciting now is that 3GPP has really jumped in full steam ahead, looking
Mm-hmm.
at, hey, how can we actually change the specification, uh, related, say, improving feedback efficiency. I think we both know that when we look at the spectral efficiency gains of cellular in
Mm-hmm.
a world with massive MIMO, in a world with millimeter wave beamforming, there's also a lot of exchange of side information,
Mm-hmm.
channel state information to enable the actual data communication pipe itself. And that's a
Mm-hmm.
great example where machine learning can help move from a more stochastic framework of modeling things into more of a predictive approach. And that can
Mm-hmm.
really, cut down on overhead, which can then enable us to more efficiently use the network resources, the Airlink resources. So I do fully expect AI to continue to be a hot topic in standardization, even as we pivot all the way into 6G designs and looking at a more AI native architecture end to end.
Mm-hmm. Yeah. So, and with release 18 starting off, you think you found a good way how the cross learning between the device AI, which is running its own algorithms and so on, and the network running its own algorithm coming from different vendors and so on. Usually the device and the network are coming from different vendors, and I'm assuming the vendors have their own models that they're not public and so on. So how is that cross learning between that working out? So you think you guys have now good framework on, you work on your stuff, and the network guys work on their stuff. You have good channels to change the information, exchange the information, and work towards an additive overall improvement and so on. So that you set a good foundation that the future versions of AI can do even better and much more features and so on.
That's right. Yeah, it's really about, as you say, it's about partitioning the opportunity for improvement, and instead of
Mm-hmm.
having separate optimizations that are happening in a very disjoint way with
Mm-hmm.
techniques like cross node. And that was actually one of our technology demonstrations in Barcelona, was one of our interoperability cross node research projects that we did with Nokia. And it was an
Mm-hmm.
interesting one because we were then able to look at some of that dynamics around what's being exchanged and how
Yeah.
that positioning then of what's happening on the device side relative to the network side can enable performance improvement and kind of a new approach to this kind of end-to-end challenge that's been inherent in wireless communications and information theory. This kind of this kind of huge framework around transmitters and receivers and channels, and this
Uh-huh.
notion of separability versus kind of mutual solution. And so I think it's really an exciting area. And what's
Uh-huh.
also important to remember is the fact that AI itself is changing so quickly. So not
Right.
only just generative AI and text to image type applications, but the way
Mm-hmm.
in which the field has evolved in a mathematical computer science context really
Mm-hmm.
is something that on the research side of Qualcomm, and I know many other companies as well, it's something when we're able to then iterate with our AI teams and come
Mm-hmm.
up with new interesting applications all the time. So one of the kind of fun parts about pushing wireless forward is that the way
Mm-hmm.
that wireless and AI are intertwined, that's
Yeah.
actually changing at a fast pace. So even though wireless had a huge amount of improvement from 2G to 3G, 3G to 4G, and 4G to 5G, well,
Uh-huh.
AI is much earlier in its kind of evolutionary arc, if you will. And that
Yeah.
makes the challenges in front of us really about how to effectively combine the two, given the fact that AI and the role of on-device processing, power efficient, and like neural processors in addition to GPUs and CPUs, it's changing
Mm-hmm.
where data is created, and it's really also changing the requirements on communications. And so we are indeed, very deeply embedded into that research path because it's that coupling between the two that make the problems more interesting.
Indeed. So look at release 18, when is 19, 20, and even 6G beyond that. So what are some of the things specifically from AI point of view that you're working on?
Think of things like RF sensing and sensor fusion and ability to really
Uh-huh.
understand in an environment to create, for example, a digital twin of the physical world. That's a good example where AI and wireless
Mm-hmm.
can really combine to enable a more immersive, communications opportunity
Mm-hmm.
that is incorporating real-time knowledge of the physical environment.
Mm-hmm.
So I think that the what AI brings into wireless is also that ability to for wireless itself
Mm-hmm.
to move beyond communications into what we call integrated sensing and communications.
Mm-hmm.
And so the role of ranging, positioning versus actually better understanding a 3D physical environment,
Mm-hmm.
whether it's an indoor factory or hospital, or whether it's an outdoor scenario for, connecting vehicles or for outdoor augmented reality.
Mm-hmm.
I think that's another, the way in which people will be interacting with their physical environments is also changing quickly from a metaverse standpoint. And so that kind of 5G evolution, AI evolution
Mm-hmm.
is also on the R&D side, something that we're taking forward in terms of how we're looking at, the 6G air interface.
So 6G, I mean, it's never too late to talk about next generation. Some people might be asking, we are still have to realize the investments that we have done in 5Gs, but from a R&D point of view, technology development has to start right now for us to see what 6G is in say 2030 and beyond. I expect it to be even a little bit later than that. So, what are you guys working on as we speak now?
When we're looking at 6G, we're actually really looking at it also in the context, of pushing 5G advanced forward. I think
Mm-hmm.
it's even what we're studying in 3GP right now on topics like AI and sensing, looking at new ways of using different frequency bands.
Mm-hmm.
Some of that's going to be applicable to 5G advanced commercial deployments that happen within the next 5 years, and some of them will be incorporated, into a new
Mm-hmm.
air interface targeting, 6G deployments that begin in 2030. So when I look at 6G, it's really about understanding,
Mm-hmm.
hey, what can we do to improve the overall operational efficiency, the energy efficiency, the spectral efficiency, not only in new bands, but also in legacy bands, FDD and TDD bands, bands below 1 gigahertz, bands, from 1 to 7 gigahertz. What are some interesting things that are happening there
Mm-hmm.
versus what are some new ways to bring in new frequency bands, between 7 and 8 gigahertz or 10 and 12 gigahertz. So there's a lot of interesting work in 6G that's about making sure we're really improving the cost effectiveness of deploying and operating a cellular network. And I think that's what's going to help the industry also
Mm-hmm.
move beyond communications into a world where there's the opportunity to bring value and monetization into sensing, into AI, into new types of more immersive communications part. So if I had to kind of summarize it, it's around kind of two major core themes of improving TCO and OpEx from a communications, efficiency, resiliency, kind of green network energy consumption side.
Mm-hmm.
And then there's the part about new opportunities in AI and compute and integrated sensing. And so what's interesting in that broader context is,
Yeah.
as we say, it's only 2024 now. And so when we look at a 6G technology that's going to be 2030 to 2040, there's a huge amount of interesting opportunities that
Yeah.
lie in front of that from a more connected smart city. And going back to our earlier chat here about the role of enterprise relative to consumer. So 6G is not really just happening because consumers need a new smartphone in 2030. There's going to be so many other things that are part of that overall efficiency improvements in the cellular networks.
Yeah, that's exactly right. I mean, so far the cellular networks were designed and standardized for public consumer network and use, right? I think going forward, it'll be even the network architecture and the deployment point of view has to change as well. It'll be more custom built, maybe one for enterprises, one for consumers, one for others, and so on. I think the whole concept of building very large countrywide single kind of application networks will have to change as well, right? Because there's so much of variance in what people use this technology for, isn't it?
That's right. And it's interesting because what we kind of talk about is the surface area
Mm-hmm.
of 5G. And if we look at the surface area of cellular
Mm-hmm.
in a 3G era versus a 4G 2010s era to a 5G 2020s era,
Yeah.
absolutely the surface area of
Mm-hmm.
cellular is so much bigger.
Yeah.
And which is one of the reasons that, whether you're talking automotive or you're talking industry or you're talking embedded IoT, there's a lot of interesting intersections that map back to, hey, I want to have cellular connectivity. I want to think about my network in a different way. I want to be connecting and bringing value of that connectivity into new end-to-end applications. And I think it's that energy and enthusiasm that in some sense underscores why there's that global interest in continuing to drive from 5G into 6G, both in an academic context, in an industrial policy context, and obviously for companies like Qualcomm in a huge, innovation pushing technology forward context.
You think 6 will have a new modulation scheme, or you think we are good with OFDMA for another generation?
I think OFDMA has a lot of inherent advantages from a efficiency standpoint, a time frequency slicing, spatialization opportunity standpoint in terms
Mm-hmm.
of that. So I do think the waveform will largely be OFDM based. We often look at some tweaks to that at very high frequency bands where we're really concerned with peak to average. So we look at single carrier waveforms for that sort of scenario.
Mm-hmm.
But OFDM is a real workhorse, 4G, 5G, and likely into 6G because of that flexibility that it affords from that time frequency standpoint. So short answer is, OFDM will absolutely be part of 6G.
Very well. So I think that was my last question. Any closing comments?
Yeah, so in summary, I think we're at that interesting point of inflection where 5G is out there today. Operators are focusing on that transition into SA, and in SA, the standalone mode bringing with the 5G core opens up new opportunities for reduced capability, new kind of end-to-end efficiencies for connecting more devices via cellular. And I think that's the interesting reality of the cellular ecosystem, the device side, the network side, the operator side, and then that consumer enterprise side. So we have an exciting 5 years ahead of us as we're continuing to see more applications move into wireless and at the same time beginning that foundational research into 6G.
Excellent, John. We can spend hours discussing this, but still have not covered everything. Thank you very much for your insights. Indeed, it is a testing time for operators and the industry. As we move from really successful 5G to the next phase and looking for where this new killer app and use cases are coming from. And it is interesting to watch how the industry moves forward. Thank you again, John.
Sounds great, Prakash. Thanks again for having me.
So, folks, that's all we have for now. Hope you found this discussion informative and interesting. If so, please hit like and subscribe to the podcast on whatever platform you're listening this on. Don't forget to check out other content on website www.tantraanalyst.com. I'll be back very soon with another episode, putting light on another interesting tech subject. Bye bye for now.